summation of horizontal forces equals 0. So horizontal forces is equal to 0 from the diagram. This is equal to 0. Summation of vertical forces equal to 0 from the condition of equilibrium. So any upward force is positive, then what does that tell you? That means downward force are negative. So if you resolve, so yeah, when we are resolving to the vertical, summation of vertical force equals 0. So the upward force, this one is an upward force, that will be plus VA. Then this is a downward force, minus 20, minus 30, minus 40. Then upward force plus VE, that's vertical force at point E. So that's how we derive this. So when you solve this, VA plus VE equals 90 kilonewtons. You call it equation 1. Then summation of moment at point A equals 0. You can take it at any point, either at point A or point B or point E. So yeah, if you look at the diagram, we are taking the moment at point A. That means at this point it is 0. At point A it is 0. It is fixed. So all the forces are coming to in this direction. So yeah, and I said if you look at it, clockwise is positive, then the opposite anti-clockwise is negative. So VE is going in this direction, that's anti-clockwise, negative, that's minus VE times the total distance, because moment is force times distance, so that's the total distance here to point A. That's VE times 12 plus, this is going clockwise, that's 40 plus 40 times the total distance, that's 9 plus 30 times 6 plus 20 times 3 equals to 0. So this is how we got this. So you solve it and get the vertical force at E to be 50 kilonewtons. So we will now substitute the vertical force at point E, at joint E or node E, into equation 1. Then we get the force at A to be 40 kilonewtons. So after we get that, the next step 3 is we are to determine the angle. If you look at the diagram, we are not told the angle. So but we were given the height and the base. So we bring out one of the triangle and we use our tan theta, because this is adjacent and this is opposite. So that's tan theta equals 6/3. So theta is tan inverse of 6/3. Then you get 63.4 degrees as our angle. So from there we proceed to solving the joints. So at joint A, note when solving for joints, you solve for the ones that is having maximum of 2 unknowns, and we assume that all members are in tension. So the next thing is draw out the free body diagram of that node from the joint A. Draw for where other members are meeting at joint A. So plus the external forces acting on the person. So you write out it. This is AB cos theta, AB sin theta. This is going to the horizontal, that's AB cos theta, and then to the vertical. Then summation of vertical forces, the upward ones are positive, that means the downward ones are negative. So the vertical forces, now what are the vertical forces here? This and this. This one is both vertical and horizontal, but we resolve it to the vertical. So that will be upward force 40 plus Then we are resolving this to the vertical, to the vertical, to the vertical. So that will be this AB sine the angle theta equals 0. So we substitute the value of angle theta, then we get the member AB to be minus 44.7 kilonewtons. Anytime you see a negative sign, that means it's compression. The C represents compression, and if you see T, it means the member is in tension. It's a tension member. So that means our assumption here was wrong, but we just assume that all are in tension. But when we resolve it, we got compression. So this member at AB is in compression, not tension. Then you solve the algebraic sum of the horizontal forces equals 0. So anyone moving in this direction is positive, then in the opposite direction negative. So for horizontal forces, this is the horizontal here, and this is having horizontal also. So that will be 0, is going this direction, that's plus 0 plus member at AH plus AB to the horizontal. We are resolving it to the horizontal, that's AB cos theta. So we get AH to be this, then our member AH is 20 kilonewtons tension. So that our assumption here was correct. So we solve. So the next joint is joint H. Remember I said we should know that when we want to get the joint, we resolve the one that is having maximum on the unknown members should be two unknown members. If it's more than, don't solve that joint. Look for the next one that is having two unknown members. So here, this is the free body diagram of the members meeting at joint H. This is it. So summation of vertical forces equals 0. So vertical force, the only vertical force here is this HB. So HB is equal to 0. So this 0 means is a 0 force. That means it's just attached to make the truss rigid and for aesthetic purpose. Then summation of horizontal forces equals 0. So anyone going in this direction is positive. So these are the horizontal forces. So this is going in this direction, that's negative. This is going in the positive direction. So that's how we got this. So we have gotten the value of member AH before in the previous part. So just substitute AH, that's 20, then we get HG. So HG is 20 kilonewtons, that's tension. So we have solved for the summation of vertical and horizontal. Note, the reason why we are solving for vertical summation of the vertical forces and horizontal forces is because when solving for joints, we solve for only these two conditions, summation of vertical and summation of horizontal, because there's no moment here. It's a pinned joint, is pinned or hinged. So we are only solving for only two, that's vertical and horizontal. So we don't solve for moment here. So we use only the first two conditions of equilibrium here. So in joint B, this is the free body diagram. We draw the forces, both the internal and external, acting at point B. So this is it. You draw the forces acting there, all the members meeting at point B. So summation of vertical forces. So yeah, these are the vertical forces. This one is going downward, that's minus 20 BH, downward minus BH. Then these ones are resultant forces. We can resolve it both vertical and horizontal. So and we are doing vertical. So to the vertical, that be BG sine theta, and it's going to this direction, that's negative minus BG. Then this also we are resolving to the vertical, so minus BA sine theta equals 0. So minus 20 BH. We have gotten the value of BH before, that's 0. Put the angle 60 point this thing. Then BA, we have gotten the value of BA or AB before in our previous joint, so just substitute the value and get the unknown. So the unknown here is BG, member BG, so we resolve it to be what? 22.3 kilonewtons tension. So we have resolved for the vertical in the joint we are solving. Then summation of horizontal equals 0 also. So summation of all the horizontal forces. So this is going this, and these are the horizontal forces. BC is going this direction, that's plus BC. Then this is the resultant for, you can resolve it to the horizontal or vertical, but we're resolving horizontally, so like this to the horizontal, so that will be plus BG cos theta. Then this one is vertical and we're doing horizontal. Then this is another one, we resolve it horizontally to the horizontal axis, so that will be BA cos theta. So that's how we got this equals to 0. So we substitute the members that we have gotten. Then BC plus 22.3, we have gotten BG in the previous joint, cos 63.4 minus. Be careful when solving, always be careful when dealing with a negative sign. So this will be minus into bracket minus 44.7 cos 63.4 degree equals 0. So we resolve it to be minus 29.9, that's approximately minus 30 kilonewtons, negative meaning compression. So at joint C, this is joint C, these are the joint meeting at the members meeting at joint C, that's 30 kilonewtons. Then you label it. So next step is you resolve it to the vertical and horizontal. So vertical first, so summation of vertical equals 0. So the vertical, these are the vertical forces, these two. So this is downward, minus 30 minus member CG equals 0. So we get CG as minus 30 kilonewtons compression. Then summation of horizontal equals 0. These are the horizontal forces. This one is easy and simpler, it's not that complex like the other joints. Then minus CB negative minus CB plus CD equals 0. So we have gotten the value of member CD before, so just substitute the value plus CD. Then we get the member CD to be minus 30 kilonewtons. So I told you the truss is symmetrical. That means what we get here is equal to what we get here. So here is this, I've simplified it for you, so just go through it. Then we show indicate there is tension or compression on the diagram. So for tension while compression is going in this direction. So anyone that is compression negative, you do it like this. Then anyone that is tension, the first is like this. So because the reason why is to every action there's equal and opposite reaction. Normally our tension is always pulling it, but to every action there's equal and opposite reaction, so it will be the opposite. Then compression too, compression is always like this, so the opposite, so go in this direction. So AB is minus for that's compression, so it will be like this. Then BC minus 30 compression, AH 20 tension member, then BH is 0, just write 0, is a 0 force member, then BG is acting as the diagonal as the strut, BG 22.3 tension, HG tension 20 kilonewtons, then CG or GC so CG is minus 30 kilonewtons, so that's compression. So you can just replicate this to this place. So yeah guys, this is it. I've replicated it here. So this is it. So like and subscribe to our channel, and I wait for more videos on this channel. Thank you and God bless you.